Okay, so we've talked about epilepsy being this disease that involves recurrent seizures and how neurologists and scientists are trying to create some kind of taxonomy or categorization tool to talk about epilepsy. And they're doing that based on essentially looking at the EEG. So we've talked a lot about EEGs over our lecture series, but let's just go back into it again. So the EEG we know is this voltage that occurs on the scalp as a result of synchronous activities of large populations of neurons, right? So when lots of neurons fire an extra potential at once, sodium rushes into the neuron, then positive charges need to leak out somewhere else. That creates an electrical circuit, and that current running around creates voltages, and we can pick those up. But we only really can pick them up on the surface of the skull when large populations of neurons are active at the same time. So um, there are lots of different EEG systems, which is to say different ways of placing the electrodes on the skull, or sorry, on the scalp. But the most common way is the so-called 10-20 system. So it has 20 electrodes, 10 on sort of each side, sort of, um, and it's thankfully got a pretty sensible naming scheme, right? So each electrode position has a ID, and that it's a letter and a number. So the letter tells you what lobe it's over. So if it's F, it's in the frontal lobe. T, it's in the temporal lobe. C, it's over the central position. P, O, is parietal lobe. O is occipital lobe. Um, if it is an even number, it is on the right hemisphere. If it is an odd number, it is on the left hemisphere. And the numbers get smaller as you move towards the midline. So even if you don't know exactly where the F4 electrode is, you know it's closer to the midline than the F8 electrode, for instance. And of course, you know it's over the frontal lobe. Now, what you usually report the EEG as is the recording at one place minus a recording in another place. So this one shows you, so this is the frontal one electrode minus the average of all of these, right? And this is because we do this something minus something else because there's a lot of electrical noise in the world coming out from computers and phones and radio towers and the power lines, but we assume that on the level of somebody's skull all of those noises will be identical. So when you do one signal minus the other, you remove that common signal and are left with only the biological signal. And this is a roughly typical EEG signal. So there's um, there's not too much synchronous large scale activity. There are some. You can pick it that, for instance, here over these frontal electrodes, you can see that there is something happens simultaneously here. There's a funny little high frequency burst of activity here. It kind of looks to me a bit like a cell phone, to be honest with you. Um, but this is not an super abnormal uh, recording. So now we're going to look at what these EEG signals look like in different uh, different categories of epilepsy.